In section 3, we're going to talk about slope. So slope is the ratio of a line's vertical rise to its horizontal run. So many of you have probably heard the term rise over run when determining the slope of a line, but there's also a formula. So if we have 2 points, one of them being x1, y1, and the other one being x2, y2, the formula for slope, so rise, which would be a change in y values, would be found by doing y2 minus y1 over its horizontal run, which is a change in the x values, would be x2 minus x1. So this is the formula finding slope between 2 points where you have the rise over the run. And it's extremely important here that the points you label x1, y1, and x2, y2, you start with the same value from each point in the numerator and denominator. So it doesn't matter which one you label, but if you start with y2 in the numerator, you have to start with x2 in the denominator. Let's go ahead and look at some examples. So we want to find the slope of each of our lines using 2 points given. So it doesn't matter which one you label to be x1, y1. So we'll label this x1, y1, and this point x2, y2. And then we typically use the letter m to denote slope. So I'm going to do y2, which is -2, minus y1, which is 2, over x2, which is -3, minus x1, which is -1. Notice how I put the -1 in parentheses. A very common mistake I see is that people will forget a negative because there's already subtraction. I see a lot of people just write -3 minus 1, but because the -1 has a negative, you need to make sure you include that and put parentheses. So in our numerator, -2 minus 2 is going to give us -4. And then -3 minus a -1 changes to addition, so it becomes -3 plus 1, which is -2. And then -4 divided by -2 gives us a slope of 2. In our second example, we have the points -4, 0, and 0, -1. So we want to find the slope between those 2 points. So first, label my first point as x1, y1. My second point is x2, y2. And again, it doesn't matter which point you choose to be x1, y1, and which one you choose to be x2, y2. So I go to find the slope. We want to do y2, which is -1, minus y1, which is 0, divided by x2, which is 0, minus x1, which is -4. So -1 minus 0 is going to give us -1 in the numerator. Then 0 minus -4 is going to become 0 plus 4, which gives us 4 in the denominator, which means we have a slope of -1/4. So we're going to go down 1 over 4 to travel between points on the line. C, we have the line with points -3, 5 and 1, 5 on it. So labeling our points x1, y1, x2, y2. The slope is found by doing 5 minus 5 over 1 minus -3. So 5 minus 5 is going to give us 0. 1 minus -3 is going to turn to 1 plus 3, which gives us 4. And 0 divided by 4 is 0, which means we have a slope of 0. So remember, we are allowed to take 0 and divide it by a number, but we're not allowed to take a number and divide it by 0. So 0 divided by 4 is an okay division to do, and it does give us 0 as the answer, which means the slope is 0. Okay. So in our last example, we have a line with points 6, 3, and 6, -4 on it. So labeling points x1, y1, and x2, y2. our slope is found by doing -4 minus 3 divided by 6 minus 6. So -4 minus 3 is -7, 6 minus 6 is 0. So here's where we have the issue. I can't take -7 and divide it by 3, which tells us we have a slope that is undefined. Anytime you are dividing by 0, when finding slope, you're going to get undefined as the answer. Okay. So in our second example here, we have for one manufacturer of camping equipment, between 1990 and 2000, annual sales increased by 7.4 million per year. In 2000, the sales were 85.9 million. If sales increase at the same rate, what will be the total sales in 2010? So let's point out what information we know. We know that the sales increased by 7.4 million per year, and we know we have current sales of 85.9 million. So we want to know if we keep increasing at the same rate of 7.4 million, what will be the total sales in 2010? Well, we know we start with 85.9, and we're going to keep adding 7.4 for 10 years. So I can do plus 7.4 times 10, since I increased by 7.4 million for 10 years, because we want to know the total sales in 2010, and between 2000 and 2010 is 10 years. So we're going to have 85.9 plus, and then 7.4 times 10 is 74. So when we do 74 plus 85.9, we're going to get 159.9, and then because this is talking about in millions of dollars, it'd be $159.9 million. That would be the total amount of money made in sales in 2010. So in our third example, we want to find the slope of our lines L, M, and N, and then we're going to compare the slopes of each of those. So we're going to have to do our slope formula 3 times. So let's start with line L, which is this line right here. So 2 points on the line, -3, 5, and 2, 2. So if we label them x1, y1, and x2, y2, so line L, its slope is going to be 2 minus 5 over 2 minus -3. 2 minus 5 is -3, and then 2 minus a -3 becomes addition, so we're going to get 5. So we have a slope of -3/5. Our second line is line M, so our second line here. The 2 points that are on that line are the points 0, 4, so x1, y1, and 5, 1, which we'll label x2, y2. So line M, so its slope is going to be 1 minus 4 divided by 5 minus 0. So 1 minus 4 is -3, 5 minus 0 is 5. So again, we get a slope of -3/5. And then our last line is line N, so our third line. 2 points on that line are the points 4, 2, which we'll label as x1, y1, and 1, -3, which we'll label x2, y2. So for line N, its slope is going to be -3 minus 2 over 1 minus 4. -3 minus 2 is -5. 1 minus 4 is -3. Now, while 5 over 3 doesn't simplify, because I have negatives in the numerator and denominator, I can actually cancel those out. So we're going to slope of 5/3. So if I look at the slope of each of my lines, I see that lines L and M have the same slope. They both have slopes of -3/5. So two non-vertical lines have the same slope if and only if they are parallel. And if I look at my lines L and M here on my graph, they do look parallel. They both are going to continue. They are never going to cross. So they are parallel lines. Now comparing lines L and M, their slopes to the slope of line N, I notice that they are opposite reciprocals. So what that means is they have opposite signs. So L and M have negative slopes while N is positive. Reciprocals means they're flips. So if I flip 3/5, I get 5/3. So two non-vertical lines are perpendicular. If and only if the product of their slopes is -1. You can also think of it as if and only if their slopes are opposite reciprocals. So their slopes are opposite reciprocals. I can also do -3/5 times 5/3, and I will get -1 as well. So both of those are the same rule. So perpendicular means the two lines meet at 90-degree angles. So let's go ahead and determine whether lines are parallel, perpendicular, or neither. So we want to determine whether FG and HJ are parallel, perpendicular, or neither. So first we have to find the slopes of those lines. So let's start with the slope of FG. So if I use G as my second point, I'm going to do -1 minus -3 over -2 minus 1. So -1 minus a -3 becomes addition, so -1 plus 3, which is 2. And -2 minus 1 is -3. So we have a slope of -2/3. Now we don't like to leave negatives in the denominator of fractions, so we either move it out in front of the fraction or we move it to the numerator. They mean the same thing. So next, let's find the slope of HJ. So again, using J as the second point, I'm going to have 3 minus 0 over 6 minus 5. 3 minus 0 is 3, 6 minus 5 is 1, 3 divided by 1 is 3. So we have a slope of 3. So right off the bat, I can tell that these two lines are not parallel. -2/3 and 3 are not the same thing. Next, we want to check to see if they are perpendicular. So it's always a little bit easier for me to identify two slopes as opposite reciprocals, not necessarily as multiplying them to get -1. While they do meet the opposite requirement, one slope is positive and the other slope is negative, this 3 is over 1, and when I do the reciprocal of 2/3, I get 3 over 2, which is not the same thing as 3 over 1. So they aren't perpendicular either, which means these two are neither. So you don't have to be either or. It's not as though two lines have to be parallel or they have to be perpendicular. They can be neither. So moving on to our second example, so let's first find the slope of our line FG. So we're going to have -3 minus 2 over 6 minus 4. -3 minus 2 is -5. 6 minus 4 is 2. And -5 halves does not simplify, so that is the slope of our line. So next, let's find the slope of HJ. So we have 10 minus 5 over -3 minus 1. Sorry, minus a -1. Almost forgot my negative. 10 minus 5 is 5. -3 minus a -1 is going to become addition, so it becomes -2. Remember, I can rewrite that in the numerator, so we get a slope of -5 halves. So the slope of both of our lines is -5 halves, and when the slopes are the same, the lines are parallel. So our last example, the first of our last example, I should say, we want to find the error. So Curtis and Laura calculated the slope of the line containing the point A at 15.4 and B at -6, -13. We want to know who is correct and be able to explain our reasoning. So let's write down the equation for slope as a refresher. So slope equals y2 minus y1 over x2 minus x1. So let's take a look to see what Curtis did. Curtis did 4 minus -13. Well, 4 is a y value. Subtract from it the second y value, which is -13. So far, so good. Divided by 15 minus -6. 15 being the x value from our first point that contains 4 minus the -6 of our second point. He remembered to change his negatives. He got 17 over 21. So far, it looks like Curtis is correct. Now let's check Lori. Lori made that common mistake I told you guys to look out for. She just did 4 minus 13 over 15 minus 6. She forgot to take into account that our second point has negative values. So she forgot those negatives when doing the subtraction. So Curtis is correct and Lori is incorrect. So Curtis, because Lori forgot the negatives from point B. Otherwise, Lori followed the formula correct. She did her y values over her x values. Neither of them made the mistake where they mixed up the x and y values from different points, being the first one in the numerator and denominator. So our last example, we have the maximum recommended slope of a wheelchair ramp is 1 over 12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 228 inches. Is the ramp steeper than recommended? Be sure to show all of your work and explain your reasoning. So we have a rise of 22 inches over, so this is our rise, over a run of 228 inches. So in order to determine if the ramp is steeper than recommended, we have to simplify this fraction. As long as this fraction simplifies to 1 over 12, it's fine. And it's a little harder sometimes when the numbers are bigger to determine if it's going to simplify. So let's start by doing a simple simplification. 22 and 228 are both even, which means I can divide both of those numbers by 2. So 22 divided by 2 is going to give us 11. And 228 divided by 2 is going to give us 114. So our first simplification gives us 11 over 114. Now, if we look, we want the numerator to be 1 and the denominator to be 12. Well, the only way for our numerator to be 1 is if we divide 11 by 11. So 11 divided by 11 is 1. But let's see if 114 is divided by 11. And we actually get 10.36 repeating pretty much, which means it's not 12, which means 11 over 114 is as simplified as this fraction gets, and it's not equal to our slope of 1/12, which means the ramp is steeper because the slopes are different. So hopefully this gave you a good introduction or refresher into how we find slope of lines, and we will be talking about how to use this to write equations of lines in our next section.